This is the very first lecture of the course Discrete Mathematics for Computer Science, Math 3340, and we will start in Chapter 1, which is the foundation of logics and proofs. Logic is the basis of mathematical reasoning and mathematical automated reasoning, and logic has practical applications in designing computer machines, in artificial intelligence, in computer programming, and so on. Logic constructs proofs. Proofs are constructed upon logic, and proofs are useful for verifying the correctness of computer program, or verifying that an algorithm produces correct results, or to establish a security of a system, or create artificial intelligence, and so on. Actually, all mathematics and algorithms in computer science and all designs are based on proofs. Proofs are based on logic, so we need to understand logic in order to create proofs. Okay. So now we will start section 1.1. So let me start it this way. Oops, okay. Now, propositional logic. First, we need to learn what a proposition is. A proposition is a declarative statement that takes a value true or false. It cannot be both. So a proposition is a statement which is either true or false. Like if I say, what is today? This is not a true and this is not false. So it's a question. So this is not a proposition. Or if I say, clean your room, nothing true or false about it. Or if I say x plus 1 equal 2, as we see here, is that a true or false? We don't know, depends on x. It might be true or false. Or we say x plus y equals z. Is that equation true or false? It might be true, it might be false. If we take for x equal 1, y equal 1, and z equal 2, then it is a true equation. But if we take for x equal 1 and y equal 1, but z equals 5, then it is false equation. So it could take both values. So it is not a proposition. To the left here, we see propositions. Here, all of these are propositions. Oops, okay. All of these are proposition. Muscat is the capital of Oman. True. Sohar is the capital of Oman. False. It is a proposition, and it is false. The sky is green. No, it's false. So it is a proposition. It took the value. The sky is blue at the daytime. True. This is a proposition. The sky is red. A proposition. It's false. Okay. 1 plus 1 equals 2. A proposition. True. 2 plus 3 equals 4. A proposition, which is false, but it is a proposition. It took false. So any statement that is either true or false, but not both, not neither, is a proposition. Okay, good. So sentences that are propositions, we will give them letters like P, Q, R, S. Like for example, P here. Ali is taller than Ahmed. It's either true or false. This is a proposition. Or Q. Faris is younger than Ali. Might be true, might be false. But it must be either true or either false. So it is a proposition. R, a proposition. 3 divides all integers. It is a proposition. And you know it is false because 3 does not divide all integers. 3 does not divide 5. A proposition S. 2n plus 1 is an odd integer for any integer n 2n plus 1 is odd for any an integer. Is that true? 2n plus 1. Or is it false? Think about it. So it has to be either true or false. So it is a proposition. Good. And in fact, it is true. Any odd integer is of that form, 2n plus 1 for some integer n. Great. Let us move to the next. Okay. What's next? Oops, sorry. So let me copy it from here and bring it to here. Oh, what did I do? Okay, sorry. Okay. Excuse me. Okay. Let's see what do we have here. Okay. So assume we have two propositions. Um, so I need to cut that and bring it in one piece like this. Sorry for that. Copy and then paste. Okay, good. Let's see what do we have here. All right. So assume we have two propositions, P and Q. P and Q, two propositions. Then we can define logical operators on P and Q so that we produce new propositions, which we called compound propositions. So compound propositions are made from primitive propositions or other compound propositions, let me say. So compound propositions are formed from existing propositions using local operators. What does that mean? If I have a proposition P and another proposition Q, then I will join them somehow to make new propositions which we call compound proposition. Okay, for instance, what is the negation? Negation here, okay, we will have, logical operators. We will see the negation, the conjunction, the disjunction, and the exclusive OR. So let's start with them one by one. So what if we have now, excuse me, okay. First, the negation of P. Negation of P is denoted this way. So let me write it here. Not P. This is called the negation of P, and it is not the case P. The proposition not P is read not P. This is the way. So if P has a value, a truth value, true, so the negation is false. And if P has the true value false, the negation is true. So not P is the opposite. The truth value here is the opposite of the truth value of B. Okay. Now let's see an example for this. If you want to see an example, like the following example. Say the statement, the proposition P is 3 is an even integer. So not P means 3 is not an even integer. So as we see, the statement here is false because 3 is not even integer, and this is true. It's not even integer, so it's not even, so it is odd. So good. Now what's next? Let's go to next. Copy and paste. Let's see what we have here. This is uh, the other logical operator, which is the conjunction. The conjunction of P and Q, denoted this way. Let me write it. B, and we read it B and Q is the proposition. Here we go, B and Q. And what is the true value of this? The conjunction P and Q is true when both, see, true when both P and Q are true, and false otherwise. Here we go. True and true give us true. And here true and false, false and true, false and false. Each one of these cases, one of P or Q is false. So the conjunction is false. Okay. So let's see an example for this. Let us assume the statement P says 7 is an integer, and let us assume the proposition Q says 7 is a negative number. Now you know the truth value of this proposition is true, 7 is an integer, and for this proposition is false. Okay, but how P and Q, what is the truth value of this? So it is true and false. So the truth value of this is let me write it. The truth value, sorry for that. So let me I need you to get used to this. Oops. Okay. The truth value is, so true and false is false. Okay, good. So what is next? The other logical operator. What is it? The OR, which we call the disjunction. So let's see. Okay, what do we have here? Here we go. The disjunction. The disjunction of P and Q, denoted P or Q. P or Q. Here we go. Okay? And it is false when both P and Q false. Otherwise, it is true. So the disjunction P or Q is true whenever one of the propositions is true, one or both of them. So, or in other words, as it says here, it is false only in one case, when both propositions are false. Here we go. So both propositions are false here, so it is false. Now here we have a true. This is true, then true and false, and then true and true. So we need to get used to saying that true or true is true, true or false is true, false or true is true, false or false is false. Above there we will say true and true is true, true and false is false, false and true is false, false and false is false. Okay. Now let's take the proposition as given above as example. P is says, okay, let me write it again here. P, which says 7 is an integer, and proposition Q says 7 is a negative number, and the truth value of these, we know this is true, this is false. Okay, what do you want from this? Let us see the following. What do you think about P and not Q? P and not Q. What is the true value of it? Also, what's about not P and okay? I should write this. Okay, let's do it. Not P and Q. Those were supposed to be example for the conjunction, but let's do them here. Not P and not Q. Okay. Now, in the other hand, let's do P or Q and P or not Q. Okay. Not P, not P or Q, not P or not Q. So let us see the truth values of all these things. Now, P is true, not P is not Q, sorry. Q is false, so not P is true. Let me write here, make it as a table. I will say this is the truth value. So we have this and we have truth values here, and same thing here. Let's make it a table. Oh my god, sorry. And let's make, sorry for all that, I need to get used to the tablet. And here the truth value, the truth value of this. Okay, let's see. Now, true and true, we get true here. Let's see. Not P is false because P is true. Q is false. Then we have false and false. Like not Q is false. Not P, sorry. Not Q is it true. So we have false and true. Sorry, false. Okay. P or Q. P is true. Q is false. Sorry, false. So true or false? This is true. Okay, again. P true or not Q. Not Q is true. So true or true is true. Not P is false or Q. Q is false. So it is false or false. False. Not P, which is false, or not Q, which is true. Then we get true. Okay, good. So these are examples for the conjunction and the disconjunction. Okay. Now, let us move to the next thing, which is the exclusive OR. The exclusive OR. Copy. Paste. Here we go. Okay, let's see what do we have here. This is the last conjunction, the exclusive OR. Here we go. The exclusive OR. It means one of them must happen. Exclusive OR of P and Q. It is written this way. The proposition is true when exactly one of P and Q is true. So if both of them, if each of them is true, then the XOR is false. Here we go. This is true, so we got false. Good. This is false, so we got false. So in order to have the XOR to be true, we must have P, the truth values of P and Q to be different. If they agree on true or agree on false, then the XOR of them is false. But if they disagree, this is true, this is false, then the XOR is true, false here, true here, they disagree, the XOR is true. Like this is an example here. Statement P, I will use all my savings to travel to Europe. Statement Q, or proposition Q, I will use all my savings to buy an electric car. So my savings are enough to do one of these things. My savings is not enough to do both. So I either travel to Europe or buy an electric car. So both things cannot happen, and one of them must happen. So both statements cannot be true, and both statements cannot be false. One of them must be true, and one of them must be false. Okay, so let me make another example here using some mathematics. Statement B, n is an even integer, Q, n is an odd, here we see an odd integer. So for any integer n, it must be either odd or even. It cannot be both. It must be odd or even, and it cannot be none. So these two propositions cannot be true, and they cannot be false. One of them must be true and the other must be false in order to have the statement P XOR Q. Found composition, here it is, and we want the truth table of it. So first we want to negate Q. Here we go. Let's do it. So if Q is true, then this is false. This is true. Negation is false. And then the negation of this is true. Now, what we need to do next, let me do it in another color. We will do this step here. P or not Q. P or not Q. So we will, in green, we will go here, this column and this column, and we will go for or. So true or false, it is true, correct? True or true is true. False or false is false. False or true is true. Good, so this is for the or. Now let's use another color, which is light blue, for this part, P and Q. Here we go. This part is this column and this column, P and Q. We will go for and. P and Q, T and T is T, T and F is F, F and T is F, F and F is F. Good. Now, what's left is to go for to make implication. Now we will make implication for all of this, for this color, implication. Now this gives that. We will go for this column from here to here. True implies true. This is true. True implies false is false. False implies false is true. And true implies false. There is something here. So P and it is sorry. True implies false is false. Did I do something bad in here? Let me see. True, false, true, false. No, okay. Everything is fine. I thought myself doing something bad. Okay, let's see what is next. We are almost done. Okay, the priorities of the propositional logic. What do you mean priorities? So which propositional logical operators, which logical operator shall we proceed before the other one? Okay, here which is called precedence. Precedence, it means which one comes before. First thing we will apply, give priority for negation, then for the and conjunction, then for the disconjunction, and then for the implications. But first of all, the precedence is given for parentheses. Now, for example, not P and Q. We will do it because negation comes first, so we will do not P and then we are done, and take the result and make it conjunction with Q and Q. And it is not this way, like doing P and Q and then take the negation. This is wrong. So this means that, okay, so negation comes first. Now, P or Q and R, which way I shall go? In here we are saying go for and first. So we will have a parenthesis here, and we get that. Go for and first, not for or. So this is not correct. Okay. P gives Q or R. So which one shall I go? Which one proceeds? Now it says here the or comes before the implication. So I will use the parentheses, execute the or first, and then do the implication. So this is wrong. So be careful for that. P or Q, then R. The or comes before the implies. So I will have parentheses here. And this is true, and this is wrong. Now P gives Q or R, so we will have a parentheses here. This is wrong. And now same thing, we will have parentheses here. So good. Now last thing we will see in this section is the pit, pite, is the pite operation where we replace the true value by 1 and the true value by 1 and the false value by 0. So we get false and false. This is or. So we get 0, and we get 1, and we get 1. It looks like adding. Here it looks like multiplication. 0 times 0 is 0. 0. Make sure I'm doing fine. And here this is 0. This is 1, 1, and 0. Now this is an example in the book. The bitwise OR. This is the bitwise OR. So OR means okay, sorry, 0 or 1. So this is 1, and this is 1. This is 1. This is 0. This is 1, 1, and this is 1. All of them are 1s. Okay. Okay. What's about the AND? The AND, this is 0, this is 1, 0, 0, 0, 1, 0, 1, 0, 0. All right. What is about the XOR? It will be good if they are different. I mean, good, it gives 1, and otherwise I give 0. 0, they are different. I give 1, they are same. I give 0. Here I give 1 different. 0, here 1, and here 1. Okay. And this is all for this section, and thank you.